Okay, first I'm going to start with the answer for today's quiz. So you needed to rewrite this as this. Okay, and then you're going to use a product rule. The first times the derivative of the second plus the second times the derivative of the first, which is just 1. Okay, so if you simplify this, you should get this. And these 2's cancel. And now you're going to need a common denominator, which is going to be radical, this is supposed to be 2x minus 3. Okay, so when I combine my numerators, I'm going to get this. And that was choice A. Okay, so now this is from the homework, and this is problem number 1. And for this one, we're doing a right Riemann sum. And so we're going to do it from 4 to 7, from 7 to 12, and then from 12 to 15. Okay, so the length of this one is 3, 5, and 3. So from 4 to 7, we want the one on the right. That's going to be 7, so that's 6.2. And then we'll do the same for each one after that. Okay, you work out this math and you get this. Okay, and you add those together and you get this. Okay, here's the only thing. So how much is in there at 15? Well, 64.9 plus, don't forget, we didn't start until the 4th hour. How much did we have when t was 4? We had 50, so you have to add 50 to that. 114.9. That was choice C. Okay, so for number 2, we're doing the area under the curve from 1 to 5. The problem is that we only have functions for values from under 3 and then above or equal to 3. So we're going to break this integral from 1 to 5 into 2 integrals. We're going to go from 1 to 3, and then we're going to go from 3 to 5. Okay, so when we go from 1 to 3, that is going to be the function here, 2, because it's less than 3. And when we go from 3 to 5, we're bigger than 3, we're going to use this one, x minus 1. Okay, so we're going to do the antiderivatives. So that's the first one. And that's going to be the second one. So let's make some room. And then we just have to substitute these values. Okay, so I'm going to start with this one here. So first I'm going to put 3 in there. So we're going to get 2 times 3. And then we're going to put 1. So that's going to be my first piece. And then plus, okay, I'm going to put 5 in there first. So we get that. Minus. I'm going to put 3 in there. That's the second part. Okay, so we get 6 minus 2, and that's equal to 4, so that part's done. Okay, we get 25 over 2, and then we get 9 over 2. Okay, so I'm just going to get rid of those parentheses inside and distribute. Okay, so we're ending up with this. Okay, so if I do my whole numbers first, I have 4 minus 5, that's negative 1. Negative 1 plus 3 is a positive 2. And then I have 25 over 2 minus 9 over 2, so that's going to be 16 over 2, which is equal to 8, so 2 plus 8 is equal to 10, and that was choice D. Okay, so for number 3, this is an intermediate value theorem, And probably the easiest way for you to look at this is to look at a graph and to say we're looking at an interval that goes from 2 to 4. And when x is 2, y is 10, and when x is 4, y is 20. Okay, so your graph is somewhere like this. I mean, of course, it could be curvy, it could be a parabola. I mean, we don't know what it is. But we just know that it goes from 2 to 4, and the y's go from 10 to 20. So there I have all these different choices here. And so let's look at A first. So y must equal 13, at least once it's saying. And yes, that has to be true, because how can you go from 10 to 20 without ever passing 13? And I'll just show you why the others don't work. So it's saying f of 3 is 15. We have absolutely no idea about that. And then it's saying that there's a maximum value on the open interval from 2 to 4, meaning no endpoints, so we have no idea about that. They're saying that f prime has to equal 5. We don't know that. And on the last one, the derivative would have to be greater than 0. If the derivative is greater than 0, that means that this function has to be increasing all the time. Well, that's how I drew the picture, but I could have drawn the picture oops. So here, sorry. So here's my 10. For all I know, my picture, looks something like that. So it's not always increasing. So the answer was indeed A. Okay, so this is number 4, and I'm hoping that these problems are starting to look a little familiar to you. I mean, you shouldn't feel comfortable by any means at this point, but you should just be starting to say, oh, wait a minute, I think I did something like that. Okay, so the water is being pumped into a tank at a rate of this, and when it was first turned on, there was 800, so don't forget we have to add 800 to whatever we're going to get. And how much is in the tank after 20 minutes? So we're going to use the integral from 0 to 20 of r of t, and we're going to solve that, and then we have to add 800 to that. Okay, so you're going to go into your calculator, you can do math 9, and this is your function right here, this piece right there, and your variable is x, and you're going from 0 to 20, and when you put that in the calculator, and you could not possibly do this by hand, so this would definitely be a calculator question, you will get this. But that's how much went in from 0 to 20, but you have to remember at 0 you had 800, so you have to add the 800 to this, and you get this, and that is choice D, because you need to round it to the nearest gallon. Okay, so I have to go do some laundry now because I just bought a new comforter because Jojo ripped up my last comforter, so gotta go. Bye.